You want to record? Already recording, great. Well, welcome everybody to the February 16th CAB call. I'm filling in for Troy today. A couple of minor updates from the CFF. We've got an exciting hands-on lab next week from Stark and Wayne. James Hunt is going to be leading us through how to CF protect and how to shield your data. I've already gone through that lab. It's pretty interesting. So you can check that out next Tuesday at 10 a.m. Pacific. I don't have any real details to share, but I will say that there is a tentative plans are shaping up for a virtual event sometime in June or July. Have more details next month or the month after the latest, but that's dates are being floated around, and yeah, should have a little bit more information than that non-information I just gave you in another month or two. Also, the technical governance meetings on Friday mornings seem to be making pretty good progress. That's in the GitHub community, GitHub Cloud Foundry /community repo if you want to check into that a little bit. Eric might also be able to add some context there. That's what I've got from CFF and PMC updates. Eric, you have some app runtime updates for us?
Yeah, sure. I've got a few highlights to share there. So release integration, they've continued with regular releases of CF deployment. I know they had a bump to major version 16 because of interface change related to some stem cell specification on some of the add-ons. And then they've also released major version of CF for K8s, again, because of a minor but breaking change in the interface there. And kubectf has also continued their regular releases. I think their latest is 2.17.12 with some bump dependencies. And then I know that Cloud Controller team and Services API they've continued marching through those remaining V3 endpoints. I think they might be done with services at this point, but I don't want to make any promises without confirmation. So maybe we can get a confirmation update from them pretty soon. And then Irene's doing a bunch of really interesting work. They've released another major version of their component release where they've moved entirely to config maps for configuration instead of templates. So that's resolving any of the templating controversy that we've had at that component layer. They also did a little spike around taking the existing CF build packs and shimming them in as cloud native build packs so that KPAC could run them with fewer incompatibilities from the Picado build packs. And then they also had an inception on the team and are looking at taking some of the initial work that they did with a CRD representation of their long-running process entity and using that more consistently throughout the internal APIs. So I think they're planning to move forward with that in the next few weeks.
Cool, thank you.
Eric, a question?
Yeah.
What's the status on bionic stem cells getting out of beta?
I know that there are some discussions that have been going on with VMware and SAP and IBM about getting that moving forward more definitively. So some of that is still in flux, but I think we'll be seeing more forward movement on that pretty soon.
Eric, I have one question. With the V3 now basically finished, will there be an announcement when the V2 clock is starting to tick?
I would expect an update on that, yeah. So I'll confirm with the other folks that are deeper into the details.
Okay, thanks.
All right, do we have anyone from the Bosch PMC? Okay, I do know that there was a Bosch release just a week ago, 271.5. Bosch is largely in maintenance, but work is still being done. So leave it at that. Anyone from extensions? Richard, I see there any updates on Stratos?
No, I was just here to witness basic stuff. I think we're spread a bit thin at the moment, so yeah.
All right, no problem. All right. If there's any other agenda items people want to chat, now would be the time. We do have Guillaume Berche from Orange, here to present a proposal on CF Marketplace. So anything else anyone want to talk about before we launch into that? Okay, Guillaume, take it away. Looking forward to this presentation. Looks pretty interesting.
Great, thanks. Thanks. Can you see my screen?
Yes.
You should see slides. Yes. So yeah, I was keen to share some of our work, and yeah, so our feeling that marketplace is still a key differentiator for Cloud Foundry, and share some of our use cases around this. And so I split this presentation into 3 parts. Maybe just a status about the usual primary use case for Cloud Foundry Marketplace, which is consuming managed service from application workloads, and comparing, making a status on their strength and limitation from my point of view, and maybe looking at open source alternatives. And a POC I've been running on, which is providing a web UI to consume OSB Marketplace from Kubernetes, wrapping OSB as mshards. So I'll be showing some of these screenshots. And in the second part, I'd like to share some additional use cases that were valuable to Range, and like to hear whether they're also valuable to other enterprise in the Cloud Foundry community and in the market. One is using Cloud Foundry to implement a way to share marketplace among multiple platforms. So that's quite similar to the ASAP Peripli Service Manager or to VMware ISM, Independent Service Manager, with a different approach, and using Cloud Foundry for doing that, most of the Cloud Foundry ecosystem. And another use case is to use Cloud Foundry as a unified onboarding tool. So this is more thoughts and screenshots for now, and not yet implementation, but I'm looking forward to touring feedback and whether that's fits similar needs. And the conclusion and discussion I'd like to have with you guys is how is the Cloud Foundry Marketplace going in terms of new features? How can this be fueled by serving enterprise use cases in this conclusion? So let's start with the first part. And so, yes, for the primary use case of consuming managed service from app workloads, just to remind us of the different use case that different steps in the user experience. So discovering offers, service definition, the service plan and their metadata, such as costs, support URLs, and so forth, and as well managing service plan visibility within orgs. And then provision the service, usually with params, being able to access a web dashboard for those managed service using single sign-on, and as well authorization using the authorization endpoint from CAPI that provides a way for service provider to know whether the user has read or manage access to the service instance. And that there's quotas, managing quotas to this to consume this service. The ability for the service user to upgrade a plan, to do maintenance upgrade that we call maintenance info, and to share service instance within these platforms among multiple space. And then there is bind to access this service instance by the application, usually credential, but as well as root and syslog, and bind and provision. And to me, the UX is just great. It's simple. It's consistent across services, and that made a great success within Range, and I think as well in the community. On the limitations, the thing that are still waiting from my point of view, the ability to send annotations that are set on Cloud Foundry entities, service instance, bind apps, space and orgs to service brokers, so they can make useful stuff with those annotations. A first-class UX to consume service logs and service metrics. Also, first-class UX to perform backup and restore. Being able to do service composition, and there are some edge cases that do need this composition, and maybe things like being able to stop and start or Hibernate and resume a service, especially for cost saving, would be quite important. But overall, the primary use case, I think, for me, is still a very important strength to the Cloud Foundry ecosystem. So what are the alternatives from my point of view in the open source community? The first one is first-class Kubernetes custom resources with two types of packaging, either operator styles packaging, such as operator lifecycle management, OLM, or maybe Helm-chart packaging. Another one might be Terraform modules, managed service. Most managed service on public cloud have Terraform modules, and they can be maybe wrapped as a custom resource. And there's an interesting project that provides a Terraform operator for Terraform modules. And another one is Consume Service Catalog, consumed OSB Marketplace through Kubernetes client, Kubernetes Service Catalog, either through custom resource or it's CLI, Service Catalog CLI, or Web UI. Those have limitation as well, and I'll get back in next slide. And we tried to work on to find a Web UI to consume Service Catalog in the Kubernetes ecosystem. There used to be KubeApps, but it was removed. And so we were discussing with the Stratos team as well on the opportunity to provide one. And so we experimented with generating Helm-chart facade automatically for each service broker to consume. So I'll be sharing some of this POC now. So yes, the goal is to provide a web UX to consume the OSB API offerings in Kubernetes. And the use case I've prototyped so far is discovery, provisioning, and I have still some work to be done with for binding and update. And so discovery, there would be learning more about the available offers, the metadata. And the provisioning will get completion and for the available service plan, completion and web form for service parameters, and as well a way to access dashboard URLs. And so the way I've prototyped this so far is to generate this Helm-chart from the OSB catalog dynamically. And the generated Helm-chart provision then service catalog custom resources, service instance, and service binding. And we'll as well query the Kubernetes inventory to look up the dashboards in the status of the service instance custom resource. By the way, those slides, I shared those slides in the Google Doc of the CAB, if you want to have access to them and click on the different links. So how does this look? I made the experiment into Rancher UI, but it would work the same in any Kubernetes UI that supports Helm-charts, such as KubeApps, and I think most of them do support Helm-charts. So this is an example of our lab environment where I have a mix of fake brokers and real brokers, but just to give an idea of the discovery UX. So, and I think on this one, we don't have icons. I have icons working with another UI, OpenShift, I believe. So when we look at an Helm-chart, this README is automatically generated with the icon and the metadata from the OSB catalog endpoints, including the service plans, the providers, the support URLs. And the service plan is interesting to get the pricing, which is available, the additional details, bullets. And as well, I mapped the maintenance info of the service plan as well to display. And when the user has finished reading the README, he can go through the generated forms for selecting the values in the Helm-chart. And one is a service plan. So you get prompt to select one of the service plan available for this the OSB service instance. The README points to full details. And if there would be additional parameters, the JSON schema available in the service in the catalog endpoint of OSB would be used to generate forms as well to prompt the user to select to fill in the required service instance parameters. And eventually there would be service binding in the same screen to allow the user to create one or more bindings. And once the Helm chart is created, the release notes element, the release note template of the Helm chart is querying the Kubernetes inventory to find the service instance custom resource that was instantiated and to look up its status and its dashboard element in the status. And so it displays the dashboard URL there. Currently, this requires, at least in Rancher, and I need to check in other UIs, this requires upgrading the Helm chart because the release note template is rendered at the installation time. At an installation time, the service instance resource is not yet populated. So the lookup into Kubernetes inventory is still missing. And so if we look at the resources that this Helm chart has instantiated, it's just a service instance from service catalog. And eventually there would be one or more service binding. So yeah, we plan to go deeper and to complete automation on this generation. And yes, we'd be happy to get feedback and suggestions on that on the repo or any question afterwards. And so I tried, so getting back to comparison about alternatives, I was listing different alternatives for to Cloud Foundry Marketplace for different use cases. So I tried to think, how do they compare really for those different use cases? And I won't go into each cell because it would take too long, just to give an idea of a color map. The Cloud Foundry Marketplace is mostly green, with, I think, great UX for all of the supported use cases. There are some stuff that are not yet supported. The concept of I was showing is using the service catalog custom resources, using the Helm facade, such as the Osb-to-helm POC I was showing with service catalog UI. And we see that I think there's many yellow and some red. And the other approaches, I think, are okay for some and are really good for some others, such as service composition, but have also weaknesses for the others. So yeah, my conclusion, my personal feeling that yes, Cloud Foundry Marketplace for its primary use case of consuming managed service from application workloads is still unrivalled. And I'd like to share with you beyond this primary use case, I'd like to share some other use cases that were valuable to Ranch, and I'd like to know whether they're valuable to the community and to the enterprise market. So there's two of them. I was mentioning sharing marketplace among multiple platforms. Sharing a marketplace between different Cloud Foundry installations, different Kubernetes clusters, potentially provision on demand, and IS tenant. So we worked on this Osb-cmdb project, which is similar in scope than the ASAP Periplay Service Manager and VMware ISM. You have the full slide deck, which I think is 50 slides over there, which I was planning to trying to share at the last two Cloud Foundry Summit, but my talk proposal were not accepted, unfortunately, so I'll try again. But basically, the idea is to use Cloud Foundry as a database and a specialized database, a database that manage service instance, service binding, and service offering. So I'll detail that. And the second use case is, which is more thoughts. It's not yet a project. It's using Cloud Foundry as an identity and access management component of the shelf to support a use case that we have, which is to provide a unified onboarding for teams that need to access multiple cloud offerings. Sometimes we have apps that need not only Cloud Foundry, but as well Kubernetes and maybe IS and some other platforms. And instead of having them declare the members and do their onboarding again and again in web UIs that are costly to develop and maintain, we're thinking maybe we can use Cloud Foundry for that. And basically to map Cloud Foundry IAM structure, org space with their members and service instance, to map that into using APIs into onboardings of Kubernetes, IaaS offers, and even Cloud Foundry. So maybe let's start with the first one, the Osb-cmdb, sharing marketplace among multiple platforms. So it's a bit of deja vu for people that know about Periply and ISM, but I'll share that again maybe for those that do not know, and there's some difference in terms of use cases as well. So we have multiple, we have a marketplace, which might be on-prem or maybe public. And as we grow number of platforms, we can have multiple Cloud Foundry platforms deployments, maybe because of geography, maybe because of security isolation or legal restrictions. As we grow number of Cloud Foundry foundations and Kubernetes instances, maybe on demand, as well as IaaS tenant, it's hard to keep a consistent consumption by all those clients of the marketplace. So we need some kind of inventory and control in between that we can act upon. So in this next slide, why do we need an inventory? When we add a new service broker, we want it to be consumable from all client platforms. So we need a consistent marketplace among those different platforms. And from a service provider point of view, as well, we want to have a consistent and comprehensive view of consumption by all the client platforms. And more generally, we want some kind of common operability for all clients and brokers. So we need a common inventory with the access, be able to access the usage history. We need to be able to trace calls from client platforms, from consumer users for apps, and to store those metadata and avoid implementing this logic in each service broker. To be able to log OSB API calls received. And in addition, we need control. So one is to unify the OSB calls received by service brokers from different platforms. There's different profile into the OSB API, and the Cloud Foundry profile is distinct from Kubernetes profile. In particular, the Kubernetes has the specificity of in its reconciliation loop implementation of applying an eventual consistency pattern, which is costly to implement in service broker. They need to handle concurrent calls and determine which one has been made first. So Osb-cmdb shield service broker authors from this implementation. Service broker authors only received Cloud Foundry profile calls, and the Kubernetes ones would be automatically translated into Cloud Foundry calls. Service providers need to control which client is consuming their service plan. So the service plan visibility use case, set limit and quotas when they run out of capacity, for example. And this is as well a good area, we think, to implement future features that we're thinking of that are not yet implemented. Things like doing soft delete and undelete of service instance in a central place. To do service instance and service binding sharing, but between distinct client platforms. For example, share a Kafka cluster between a Kubernetes instance and a Cloud Foundry instance to be able to share messages. And potentially doing recharging as well and stuff like that. So how does it look? And what are the different actors that are supported into the system? So we have our usual application developer that uses platform to host his application workload and uses native API and web UIs to provision manage service, no change for him. We have service providers. So service provider register into the central component their new broker. They manage the service offering visibility, they manage their quotas, and they can as well look up the content of the inventory, list, service instance, and service binding that were provisioned, access the metadata to know which platform it was, which client, which tenant it was within it. It can be a namespace, it can be a Cloud Foundry, org space, application instance ID. You might want to get analytics, dashboards about consumption of its services, maybe alerts if there is a loop, an uncontrolled loop that created 1,000 dedicated cluster in his in a faulty CI/CD. and maybe as well receive alerts when there is something wrong happening. So the central components come with its CLI, its web UI, its analytics web UI, its monitoring and analytics, so a whole lot of ecosystem. And basically it receives OSB calls from client platforms and translate that into OSB calls for brokers. And it keeps an inventory of everything that was provisioned. And it might use this inventory to export it to corporate CMDB somewhere else. And when we were thinking about implementing this, because Periplay was not suiting our needs, and I have an issue, a public issue that describes the reason on the homepage of the repo, and the ISM was made closed source. When we were considering how to implement, we were thinking, well, do we start with just a plain database for managing service instance, service binding, service offering? And we have to re-implement all this tooling, ecosystem tooling, or can we use a specialized database? And we're thinking, well, Cloud Foundry is a specialized database. It manages service instance, service keys, service offering, and service plan. Can we just use Cloud Foundry as a database? So, and then we would be able to use its tooling, its CLI, its web UI, the existing analytics that we have, database analytics for querying the Cloud Foundry content, as well as the Prometheus exporters and the Grafana dashboard for monitoring services. Can we use all this ecosystem to access this specialized database and maintain our inventory of services? And so basically, that's what we do. The Osb-cmdb service broker translate OSB calls into Cloud Foundry service API calls from CAPI. And then Cloud Foundry Cloud Controller translate those CAPI calls into OSB calls to service brokers. So that's basically a thin layer of translation between OSB calls and marketplace calls. So let's look at that in a bit more details. When a client platform asks for the inventory, the catalog endpoint, the broker just look up the marketplace into the inventory, into the database, into Cloud Foundry, which was provisioned previously using the native Cloud Foundry tools, CF Create Service Broker. When a user asks to provision a service instance, the broker translate that into a space creation, a dynamically space creation, then the creation of a service instance, and then it adds some metadata into the service instance to be able to track origin. When the user asks to do a service binding to its platform, which translates into these OSB calls, this is translating into the creation of a service key. So how does the CMDB looks like, content? We choose to have one org per OSB client. So in the example, I had 2 client platforms, CF1, CF2, and 2 Kubernetes platforms. So I would have 4 orgs. In each org, we have 1 space per service definition. So in this example, I have Cassandra MySQL, and this dummy space. And then for each service instance that are created by requested by user, we have a that we call brokered service instance. We have a backing service instance there. And then for each service key, for each service binding requested by the user, we have a service key. So yes, there's more details in the slide deck of the using of the community ecosystem. So Stratos to look at the content of the inventory, and the Prometheus dashboards, Grafana dashboards to look at the rate of consumption of marketplace, alerts when a service instance is failing, the CLI and CLI script to do some analytics on the content of the database. So there's more detail in the flow deck. And our roadmap is public. And as well, we were wondering whether there is interest in the community that this project gets incubating into the PHN, the extension PMC. So we are happy to move out the repo if it makes sense and if there is interest. So I'd like to go to now second part beyond the primary use case of consuming managed service by application workloads. It was the case of going through unified onboarding. So in this other usage of a secondary usage of Cloud Foundry, we use Cloud Foundry as an IAM. And so this is an overview of how the user experience for projects that need to consume multiple platforms, maybe to onboard on different Cloud Foundry deployments, and maybe as well on Kubernetes, because the application is not eligible only on Cloud Foundry. It needs some Kubernetes support as well, maybe some IaaS support as well. We have some applications that need multiple platforms to fulfill the diverse needs. And they don't want to declare their members into each platform and to do their onboarding multiple times. So in this scenario, they would create a project, declare their members, and then the project members would be automatically available when they ask for a platform tenant of Kubernetes, Cloud Foundry, or IaaS. When they create a platform tenant, the project members would be automatically created and updated. And then from each platform, they can consume the marketplace as they usually do, still having the centralized CMDB, keeping an inventory. So those platforms can be public or private. We keep a central unified inventory of all project subscription to platforms, and as well as all project subscriptions to service provider, being public or private. So let's look at how this would appear using Stratos and Stratos in Cloud Foundry community project. So the project manager arrives on Stratos and discovers an onboarding offers to declare its project and its members. And there's multiple plans in this onboarding offers. He can declare that he just wants to do a self-training, and a self-training is maybe limited to a single user. It has limited quota. Or he can declare an experiment. If he's declaring an experiment, then he can invite teammates to share his cloud subscription. Or it can declare a real project. And so in this case, this is subject to internal recharging. He needs to provide a recharging code. Then he has maybe unlimited number of members. And there is maybe the default pattern of separating prod, non-prod, dev and QA members. And maybe even might think of having different leases, duration leases for subscription. We see the pattern that many times people on board for experiment of self-training, but forget to close those resources. And so these resources end up consuming a lot of physical compute resources. And this creates environmental issues and financial costs. So having an automated list for the different projects would be nice as well. So the user end up into an org. So let's use Cloud Foundry. Thinking, can we use Cloud Foundry IAM as a way to declare this project? So the project manager or the project members end up into a default org with space by its name. That's my internal name. And then he chooses which plan. So in this case, he declares an official project, the name of each project, and potentially service parameters such as recharging codes and other stuff. And so that's a service instance in the marketplace. So that's the way he declared this project. So the dashboard brings the user to the org created. He had selected that's a real project. So it has created, the service instance has created into Cloud Foundry, an org and multiple space. One space for development teams, another space for QA, another space for prod. And using Cloud Foundry UI, using Stratos, he would then add users, his project members to the different space, and basically provision the IAM. So in this case, it's adding Pierre and Guillaume to those different space with the different roles, being developers, auditor, manager. And so it might as well choose, in addition to the official project, to work on an experiment. So we create a second service instance for an experiment he's working on as a side project, and maybe another one for self-training. So basically, using the marketplace, provision into Cloud Foundry the different elements that are then used to onboard users. So we've seen the first part, creation of project, setup of members. Now we look at how to create platforms into the different tenants. So the user needs now to provision a Cloud Foundry tenant on Argo space, or provision a Kubernetes tenant, might be on-prem or public, or cluster, or even a IaaS tenant. So how does it look? Within its organ space, any space member can now have access to a list of service offerings, which corresponds to the different service cloud service offerings. So in this case, we have a Cloud Foundry organization. That's our internal name for Cloud Foundry instances. In this example, that's a Kubernetes tenant, a namespace, and we have IaaS as well. So let's take the example of a Cloud Foundry tenant. In our case, we have multiple Cloud Foundry deployments, one per AZ for specific reasons, internal reasons. And the user can choose to onboard on one AZ, two AZ, or multiple AZ, all AZ available. And then it choose for which team this subscription is for the dev team, QA team, or prod team. So in which space, if he's a member of all of them. And so the service broker that supports this service offering would provision into Cloud Foundry and the proper org and the user associated to that. So the way we're thinking of implementing this is using the cloud service broker, which was contributed by Google and is now maintained by VMware and the Cloud Foundry community, which is awesome. And to use the Cloud Foundry Terraform provider as well. I provide some details. So the way it would work is that the service broker would look up where it was called from and look up the team members into the calling space and provision those users into the created org. And so the dashboard brings to the Cloud App offering, in our case, or Cloud Foundry instance. And member provisioned can log in using SSO, and I've already there their roles aside. So that's an example of multiple subscription made. So a user, they provision multiple Cloud Foundry subscription, multiple Kubernetes subscription, and they can log in into each one into a central space. So that was the part about onboarding. And then once they're on board, from each platform, they can consume the marketplace using their native platform UI. So Cloud Foundry Marketplace for Cloud Foundry and Service Catalog, for example, into Kubernetes. Still keeping a centralized inventory and control for all activities. So the way I'm considering how to implement this. So on the left, we have the app hosting platforms. So it might be Cloud Foundry, Kubernetes, or IaaS. So that's easy for Cloud Foundry. They consume the marketplace from Stratos or from the vendor UI. And then Cloud Foundry has an OSB client, which goes to the Osb-cmdb. And then from this, they can consume service broker for data services. So we see similar ways for Kubernetes, I was mentioning Osb-to-helm. So the Helm-chart UI for OSB. We're working for IIS as well. Some of our team use VMware Realize Automation, VRA. Some other use OpenStack Horizon. So we are considering, for example, using Stratos UI for having them consuming the Cloud Foundry marketplace. We're also considering generating automatically in the same way that Osb-to-helm VRA tiles and maybe OpenStack Horizon UI for having native marketplace consumption into VRA and into OpenStack. For the first onboarding case that was showing, creating a project and then onboarding to platforms, the user would end up into Stratos, discover service offering. This service offering would be supported by the different onboarding service broker. Sorry. So we are considering using the cloud service broker with the Terraform service provider, and the cloud service broker supports this concept of broker pack. That's the name for calling Terraform modules. And so basically, there would be one module that would instantiate an org and a dev, QA, and prod space. In the example for the service plan project I was showing. This Terraform modules would also use data sources. A data source is a way to look up an existing object into real world, and the data source would just look up the context of the OSB calls. The context being which space, apps, and org the service instance was created. So when a user has created a project and then asked to create a Kubernetes subscription, the service broker knows that it was asked from the production space of this project. And so it can use a data source to look up the members of the space, and so to provision into Kubernetes namespace the users that are members of the space, and to update that correspondingly. So I'm about done for this second part, which was thoughts for now. And yeah, I'm quite interested to hear whether there is similar needs into other enterprise. And that comes to my conclusion and discussion I'd like to have with you guys. And so my feeling is that Cloud Foundry Marketplace and the OSB ecosystem provides strong value to range, and I'd like to confirmation that it's also the case to the enterprise market. And that there's still quite a bit of work on those components to support advanced use case and to support those enterprise use case. So I was mentioning, for example, the sending annotations to service brokers. There is maintenance into Stratos for enhanced experience of the Cloud Foundry Marketplace, as well as V3. The CF Java client is great. It's a great asset that allows to develop service broker that talks to Cloud Foundry, such as for Osb-cmdb. V3 support is being contributed as well. And thanks again from VMware and the SAP for those great contributions. Cloud Service Broker is awesome. There are many as well opportunities to serve those enterprise use case with additional use cases, such as support for dashboards. Currently, Cloud Service Broker doesn't support dashboards, and I think I'll share another presentation detailing one use case I was missing. Is once a user created a data subscription, say a GCP, a Cloud SQL service instance, and that it needs to access GCP console to access log, metrics, alerts, or backups. Currently, from Cloud Foundry Identity, it has no way to get into a GCP console. So the idea is to find a way so that either CMDB or the cloud service broker would set up into the service provider IAM. Let's take the example of GCP IAM, the different user and roles so that the user can natively then access the console with restricted permission. So that's a subject maybe of another presentation where I detail some of that. This ecosystem is strong as well because of the Kubernetes client, service catalog. Maybe a UI is missing, so I'd like to get feedback on whether this Osb-to-helm POC is interesting to the community. And as well, it's strong because of the service brokers that provide a way to provision Kubernetes resources. So there's ACP Service Fabric Broker, which I do need to test. There's a cloud service broker that looks very promising as well. Using Terraform providers, Kubernetes Alpha enables custom resources to be provisioned. It's still alpha as its name indicates, so we do need to test that. There is the Kubernetes provider, and there was a great example contributed by the cloud.gov team, GSA, EKS Brokeback example, which is very promising. So the Helm provider as well, and there was an issue provided by GSA team as well on that. There's many brokers that looks promising as well, maybe others. So yes, the discussion and question I was keen to receive was, do those use cases that I was sharing, do they also apply to enterprise customers? Is there a way that Cloud Foundry downstream vendors could leverage the marketplace to serve those enterprise customers, advanced use case, advanced use cases? And would that be a way as well to help maintaining this ecosystem that I think is still differentiating from an ecosystem, but gradually is getting competition, and so is probably threatened by investment made into the Kubernetes ecosystem. So yes, that's the discussion. Maybe we can move to more discussion Q&A. I'm done with slides for now, and yeah, I'd like to get your feedback. Can you still hear me?
Yeah, thanks, Guillaume. That was fantastic. Yeah, definitely interested to hear what the community has to say. Are there any questions? Well, got a fairly small audience here today, but I think at the very least you should post this in CFDev, try and reach out to the wider community and see what kind of response that gets. And yeah, we can talk how to move forward with this. But yeah, it looks really interesting. I'm also very excited about the Cloud Service Broker project. So yeah, it is, I guess, yeah, CFDev would probably be the best place to move forward with this. Slide deck, if you can post that in the cab channel and or CFDev, I think that would be useful. But yeah, thanks so much.
Yes, and I see, thank you very much. And I see there was discussion on the chat I had missed. Yes, Norm say that he see enterprise usage. Same from Wayne. And yes, I'll follow up as well with Troy on the PMC extension for incubation, if there is interest in incubating the project.
Great.
And yes, if there is, I'm happy to get offline feedback, maybe from service teams, cloud service teams as well. And thank you very much for your attention.
Thank you, Guillaume. That was great.
Yeah, I just wanted to add, Chris, that I was very interested in the cloud service broker aspect as well, and see if there's any overlap there, or if there's some lessons that we can pull out of this. And thank you for the presentation, Guillaume. I'll reach out to you probably outside of the call and get some more info on those aspects that I just mentioned.
Great. Thank you. With pleasure. Yeah, please.
All right. Well, I think that about concludes it. So we'll give everyone a few minutes back. But thanks everyone for joining. And yeah, Guillaume, thanks again. And we'll all talk next month.
Bye. Thank you.
Wow.
Thank you. Bye-bye.